Hi, I'm Tim Berglund with Confluent. I want to talk to you today about 5 ways to get event-driven architecture right and maybe a few ways to get it wrong. I think as a community, we're increasingly persuaded that event-driven architecture is a good idea and it yields more benefits than it costs us. And a lot of us are new at it, but we're not so new that we don't have some lessons learned, right? Like we have some idea how to do this well and, maybe some paths not to take. And this talk is really just 5 things to do well, 5 things to keep in mind to make sure your projects succeed. Now, I might want to just take you through a little bit of what I mean by event-driven architecture. And the diagram I'm about to show you, the system I'm about to show you, you may have seen that before. In another talk, if you've seen me give other talks on this topic. It may look familiar. It really is kind of the reference architecture that I use just to talk about this topic. And what I love about it is it's so useful, it's so flexible. So we've got a system here, and this is an e-commerce system. Now, you may not be in e-commerce at all. You might be in some completely different business. That's fine. But this is something that we can kind of understand, right? We've got some microservices. Over on the left, we've got an orders service that takes orders from some external user interface. There's some web and mobile front end. It throws little pieces of JSON at some REST endpoint, let's assume. And there's a user service that helps users keep track of their accounts. So again, there's a front end. It's in the mobile app, or it's in a web front end, and little pieces of JSON arrive at a REST endpoint. So let's walk through an order. That order UI over there on the left, it's going to submit an order. And what's that order service going to do? It's going to validate that object that it receives. And then if this is an event-driven system, it's going to produce it to a Kafka topic. All right. And simple as that. Now, its work is done as an order service. It said, hey, here is a validated order. The rest of you, whatever you want to do with it, you figure that out. And the payment service is certainly keenly interested in those. So it consumes from that topic and it says, okay, I've got a new validated order. Let me settle that. Let me go get that order paid. And so what does it do? Well, it talks to some external payment gateway. That's probably a synchronous interface, right? A lot of those are. And so it makes a call and it gets an answer back. It says, okay, this is, maybe a second later or something. It's, this payment, this credit card number is valid. And so, okay, now you've got a settled order and the payment service can produce that event to a topic. Here is a new event, a new piece of information. There's this order and it has been paid. So we want to ship it now, right? So the shipping service is interested in those paid orders. But here we have a problem. Now that shipping service would like to just say, hey, warehouse, go pick this packet, do whatever, and make this thing get sent to the customer. But all it has is a user ID. It doesn't have a name and address. And to ship it, it's going to need a name and address. Where do name and address live? Well, obviously they live in the user service. And we don't want to have access to that user's database. We've been told that's bad for services to share databases. And it certainly has been a great way to make microservices not work. So what do we do? Well, here's another cool thing that we can do using KSQLDB or Kafka Streams. You can very safely make a copy of that data. And here's how you do it. So that you see the user service has got that database, and I'm being vague about what that is. That could totally be a Postgres instance. I mean, it could even be Oracle. I don't even know. It's just some database. But when somebody creates or updates or deletes a user account, that user service is going to produce a message to a topic. That's like a change log of the user's database. And whether that's programmatically producing that, or that's Kafka Connect doing change data capture on that database, or that database is really a Kafka Streams K table. Like, if you kind of know the internals here, there's all kinds of details that just don't matter. What matters is we need to be able to do lookups on user ID and probably lookups by email address. So that database is there. And we want to be able to share that. So we're producing that change log to that topic. And this is immutable. This is a record of, or rather a sequence of immutable events. It's a topic. It's a log of events. So the shipping service can very safely consume that topic and materialize its own local table. And we could just say that could be a Kafka Streams K table. It could be a KSQLDB table. It doesn't need to be too fancy. We just need to do lookups by key, by user ID there. And so we can materialize our own view of that immutable data in the shipping service. So not only are we able to loosely couple services, but we're also able to share data, which turns out to be a tricky thing with microservices. You can do it safely because we're sharing immutable things here, and that local copy is, of course, read-only in the shipping service. So anyway, now that it's got the name and address that it can quickly look up from the user ID, it can produce a ship this event to some topic, which you'll get picked up by a shipping subsystem elsewhere, and away we go. So when I say event-driven architecture, here's an example. This is an example of what I mean. And we're going to refer to this for the 5 patterns that I'm presenting to you. I'm going to use this system as much as possible. Now, let's look at these 5 things we ought to do to get this right. Number 1, only use it when you need it. I mean, this is almost a negative thing, but I think event-driven architecture is a fantastic paradigm. I think it truly is a paradigm that's going to endure for the next generation of systems, and people who aren't even working as professional architects and software engineers yet are going to learn a better version of this in 5 or 10 years. I think it's here to stay. But no architectural paradigm is good for everything, right? If I were to say, this is the paradigm, use it in all cases, I would clearly be, working on commission or something. That's just not, and even so, people who work on commission don't say things like that. That just gets you in trouble. So, it's only good some of the time. So we'll talk about times that it's not. Databases. Now, I talked a little bit about that users database and hinted that it could be a Kafka internal thing. It could be a regular relational database. It could be a MongoDB. Databases are a part of your life. Event-driven architecture changes the way we think about databases, maybe changes the place of primacy that databases have had in our architectures, but it doesn't make databases go away. It might make there be more databases. I don't know yet, but you need to keep databases in your life. So we'll talk about that. Schema. Schema is very important, and we'll look at that. Schema really becomes almost the API contract between systems or services in our system. So we'll talk about the great value of managing schemas. We'll look at stream processing. So when we're consuming messages, what we'd like is for each message to be a self-contained unit of work that I can just atomically consume, maybe using some Kafka consumer API for my language of choice. I just get this thing and I go do my work on it, and it's great, right? Maybe I need to do more. Maybe that atomic unit of work isn't available in one topic and I need to join 4 of them, or I need to compute an aggregation or something like that. So don't reinvent all that stream processing work. We're going to look at some of the compute layers that are available in the Kafka and Confluent ecosystem that are very important. You don't want to redo all that work. And also managed services. We'll talk for a while about that. This is operationally difficult. You don't want to reinvent the wheel there. So we'll look there. Now, let's dig into these in detail. The most important way to get your event-driven architecture right is to be using that paradigm when it's appropriate. As I said before, if I presented to you an architectural paradigm and said, this is a solution for all problems, that we're not really considering things in a mature fashion, okay? This is true of event-driven architecture as well. Now, here is a painting by an Italian Renaissance artist, Raphael in particular. It's called The School of Athens. What does this have to do with event-driven architecture? Well, it has to do with a lot of things. And I got to tell you, I've been using this painting in technology talks for like 10 years for all kinds of different concepts. There's a reason why it just comes up a lot. It's because the 2 guys at the middle. Now, everybody in this painting is somebody, either from Renaissance Italy or from classical antiquity. And, you can go on Wikipedia, you can find a little outline of who's who. But let's look at those guys in the middle. Okay, those are the ones I want to talk about. The guy pointing up to the heavens, to the realm of fixed eternal ideas, that's Plato. The younger man kind of saying, no, let's keep it down here, down here on Earth. That's Aristotle. And, the philosophical conflict, I think, they align. These days, they would look a lot more similar than they did at the time. But the conflict between them just sets up a lot of things. And without going into that in too much detail, what I want to say is it's not like when you use event-driven architecture, everything's an event. Or if you don't use it, everything is state. You don't get to choose one. You get to prioritize state or event. But even when you have a state-based system based on a database, there are still events. Even when you have an event based system using Confluent, there's still state. So you might be a Platonist or an Aristotelian, but you still have to, you're still really drawing on both of those things. So when is this paradigm not appropriate? And when might you decide to prioritize state rather than events? When scale is very small, when it's a very new thing, just budding, you don't need help managing complexity or emergent growth or anything like that. And there's emergent design happening, but that whole application fits in your head. And maybe it's better to just use a database and a monolith. You don't need some big fancy scalable thing with lots of moving parts. Just write the program. If it's small, that's probably a good idea. And if you think about the way we use the word monolith, that refers to something big and scary, right? If it's a really, really small monolith, you don't say monolith. If it were a little rock, these Australopithecines in 2001 wouldn't have been too afraid of it. But if it's a big thing that suddenly appears there, well, that's scary. That's think about it. Monolith is usually big. And so if it's small, maybe still it's technically a monolith, but it's not bad. So that's okay. When uncertainty is high, right? Early in a project, you're really experimenting. You don't know where your scale edges are going to be. You don't know where the complexity is really going to land in the system. Maybe stick to something not event-driven and just state-based. And it may sound like these are the guidelines for when not to use microservices. And to some degree, they are. These two things align. Microservices are not the same as event-driven architecture, but there's a huge and I think increasing overlap just empirically in the way people build the systems. So when uncertainty is high, when you're just starting down the path, maybe you don't need events. But once you understand the system, once the system is growing, once complexity is becoming too much for you to manage, then you know what to do. Now, I'm talking about whether to monolith or not. I want to make it clear. I'm not talking about whether to use synchronous integration of microservices. So if I've decided to build a distributed system, and I've got lots of services, many small programs, that sort of thing, events are likely to be a better approach than RPC calls, than HTTP, REST, gRPC, things like that between services. Synchronous integration of services, I think, is working out to be a less good idea than asynchronous integration. So I'm really saying, do we monolith or not? Not do we synchronous or not, because we probably don't want to use synchronous things. Number 2, how to succeed. Second way to succeed with event-driven architecture, keep databases in your life. The presence of centralized databases is not a failure, first of all. Okay, now, event-driven architecture sort of takes the database off the throne. Ideally, the database is not the system of record. It's a materialized view of the sequence of events, which themselves are the system of record. So the system of record becomes events in a topic inside Confluent somewhere. A database is a way to look at that. But, you still have legacy things in your system. That's okay. These old paradigms, we don't just nuke them and build a new thing. I mean, you get fired that way by just trying to rebuild some trustworthy legacy system. That's a terrible career move. So we tend to supplement existing systems and not supplant them. That's very important. And so there are still going to be centralized databases in our lives, and we'll still use things like change data capture to get that state into topics so that we can now make it a part of our new event-driven world. But it stays there. That's okay. And as I said, change data capture really is the tool that lets data in motion coexist with data at rest. And we've got lots of great resources. I'm not really talking about it in any detail today, but the Confluent podcast, we've talked about CDC a lot. There's some great stuff on Confluent Developer. I'll give you a URL for that later. So we got lots of resources for this that you can dig into. And it's okay. You need to remember it's okay if you have databases doing important work. You might even have, as you do this kind of database event trade-off, you might say that there are skills that you need to acquire, like balance beam here. My middle daughter did gymnastics as an adolescent and a teenager, and balance beam was always so scary to me to watch. It looks like you're about to hit your face on this thing up in the air, and there's a lot of skills required for that. And event-driven architecture, sometimes I talk to people and it feels like they feel that way. Like this is as hard as balance beam, and I'm going to hit my face on something. And, so you might decide that for a given project, it's maybe not the thing that you want to do because you just don't have all the skills there at the moment, and so you want to keep databases as central. Now, that's a bad plan forever, and if skills are the problem, then I would direct you, perhaps somewhat self-servingly, to Confluent Developer, which is our online learning site. So basically everything you need to know, at first blush to get started with Confluent Cloud, KSQLDB, Kafka, event-driven architecture. It's all there. And remember, databases are good at things. So we talked about this little guy over here. And I said, hey, maybe it's a K table. Maybe it's a KSQLDB table. That's fine. Maybe it's a Postgres table. Don't be afraid for that to be a Postgres table, right? That's okay. Everything doesn't have to be inside the Kafka ecosystem. Likely, that user service is going to have to look up users by user ID, first of all, right? Hey, show me my user account. That's a lookup by ID. I forgot my password. Well, that's a lookup by email address. I don't know my user ID. So that's a second key on that table. So, there's a good chance that that's just a relational database table, or it's a Mongo table with multiple indexes, something like that. That's a completely fine thing for that to be. Now, in this case, we're going to want that to probably be a materialized view of that topic, that change log of all the changes to the user's state. You want to make that you want to use the database. You want no allergy to databases, but you want to make sure you are keeping the system of record as to be a log, to be a topic, and using your database as a materialized view of what's in there. But I think it's an immature approach to event-driven architecture to try to expunge databases from your life. And so make sure you use databases in an appropriate way to use those tools where they belong. All right, third way to succeed, manage schemas. So let's look back at this topic here. That's where you had validated orders being produced there, and the payment service read them to know what to go do with the payment gateway, right? That was the integration there. And even there, now it's likely that the orders service and the payment service are going to be versioned separately. And so they need to be able to evolve that schema and cooperate with each other in evolving that schema. When you use Confluent Cloud, you get included with Confluent Cloud a fully managed Confluent schema registry, which helps you do that migration management, that schema evolution management in a safe way. But there's more even than just that. Just knowing what those schemas are lets services evolve. What other things might one want to do with orders? Well, one might want to detect fraud, for example. I want to consume those orders and see if something looks fishy to me. One might want to build a customer loyalty program that has to read from that same topic. Well, to build those services, I need to be able to go somewhere and say, what's in this topic? What do the events look like here? Those schemas need to be centrally managed, and I need a way of going to that central management point and saying, please tell me the current schema of the messages in that topic. Again, if you use Confluent Cloud, this is built in. You can go to the topic. It's going to tell you the history of the schema, and I can get, say, an AVSC file. If I'm using Avro, I just get that file and build the code. You can also centrally manage your AVSC files or your protobuf files or whatever it is that you do in a Git repository and collaborate around that change in Git, like you would with collaborating around the change of any code. So lots of ways to do this, but Confluent Schema Registry tends to be a central part of that story for unlocking not just the ability to version services independently, which is a key thing you need to be able to do with microservices, but also to be able to evolve new ones. Now, we've kind of been told for almost coming on 10 years now that microservices were going to let us do things like this. And the first few years, it really wasn't obvious that it was happening, but it seems to be happening now. And especially, I think event-driven architecture is a key driver of those evolutionary systems. And speaking of Confluent Cloud, here is Confluent Cloud showing a topic with a managed protobuf schema. Now, Avro is a lot more common, and protobuf is a thing that has cropped up more recently in the Kafka world. But here you go. This schema is just right there in Confluent Cloud. I've got that file. I can download that. Build a new service based on that. I know what's there. I need to know what's there. And remember, I started off with the School of Athens and Plato and Aristotle. Well, we've got events here, but this is really a thing. Events represent things. And so I need to keep a handle on the fact that the fundamental nature, the thingness of the events in my topics, this is sort of a nod to Plato, that matters. Even while I also say, well, the things that are happening down here on Earth are also super important, which is that's a pretty unfair summary of Aristotle. But, hey, these are big guys. They're hard to summarize. But, calling back to that painting, this is really that thing, event, interaction happening. And this is why we've had a lot of conversation around data mesh recently. It's really kind of like a microservices for data. This QR code here is a link to the London Kafka Summit keynote 2021, given by Zhamak Dehghani. And she's the founder of the idea of data mesh. She gave a great description of it. These 4 principles, she said, are the important things, that analytics data should be owned locally, not by some central infrastructure team, but by the developers who build the services that produce the data. And they should take a product mindset to that data. They should be thinking about how is it that this data, what's a good way for this data to be represented? Is it documented? Is it in schema registry? Can people find out what it is? Am I really releasing that data as a product and not merely emitting rows in some database or events in some topic and forgetting about them? And this needs to be available everywhere, subject to governance. Of course, this data needs to be accessible. If I'm producing it, other people in the organization need to be able to get to it. And there's also, speaking of governance, there's a great federated approach to governance. I won't get into that here. You should really go look at the talk. We've also got a nice course on Confluent Developer. I gave a QR code for that earlier, but that's just developer.confluent.io. That's a course on data mesh there, where you can get a deeper dive into some of these ideas. But as you think about schema, I think you're going to begin to ask questions that I think data mesh is answering. So that's a good thing for you to check out. 4th way to succeed with event-driven architecture, please don't reinvent stream processing. Stream processing is very hard. Person decades, maybe person centuries have gone into this already just in Kafka. I haven't measured it, but a lot of people have been spending a lot of time on this to develop things like Kafka streams and KSQL DB. And there's just a lot to do. Now, writing events into topics, generally pretty simple. Reading, maybe it's better to give than to receive, but it's usually harder to read than to write when it comes to data. And event-driven architecture consumers are no exception. So if you don't use the tools that are available to you, you're going to feel that. You're going to spend a lot of time. So remember how consumers work in Kafka, right? You've got this topic, it's partitioned, and I've got that consumer, just consumer A there. That's just reading all of the messages from all of the partitions. Now, if I can stand up a second consumer easily enough, right? And it can also read everything because reading is non-destructive. This is so I can have new consumers evolving and emerging from that data. But I can also scale out a consumer, right? So if I add a consumer to an instance of consumer A, the partitions reshuffle. And if I add another one, well, I've scaled out yet again. The partitions reshuffle again. And that's super cool that works. But this native consumer API, like you'd like to be able to use this, but it doesn't really do much to help you manage state. It delivers key value pairs to you. So here, please take this message, this event for your computational pleasure, but everything else is on you. If you're scaling out like a consumer group does, and you're doing some kind of stateful operation, well, when you scale out, you're going to have to move state around between instances or go put it somewhere where you can get to it. Boy, you don't want it. This framework does nothing for you. The API doesn't help you with that. What if you want to compute an average over the last 5 minutes of something? There's no windowing. There's no aggregating. That's all stuff you have to do. And you might be tempted to write that because it sounds fun, but given that this is really what you get key value, you get key value pairs. Writing all of that is, as Admiral Akbar would say, a trap. You don't want to get sucked into writing a bunch of interesting distributed state management stream processing code in your consumers. If you can create events that contain everything that a service needs, and that service can consume that event atomically as a single key value pair using that Java API I just showed you before, whatever language you're using, good. But if you're doing any kind of windowing, aggregating, anything stateful, enriching, joining a stream to a table or a stream to another stream, don't write that code. That's a trap. And that happened here in our system, right? This is a state management problem. So that user's change log I'm creating, anytime a user changes, updates, deletes his or her account, I'm producing a message to that topic. And I said we want to consume that topic inside the shipping service and now create a stateful table there. That's a lot of boilerplate. If you just think about how you do that, and now think about how you scale, and what if an instance of your shipping service, if it's scaled out to 2 or 3 instances, what if one of them goes down? How do you move the state? That's a lot of work to do. All right. I mean, just think about how hard this is. Like I said, we're at 2 consumers and now we're at 3. So we'll go back. 2 consumers. The top instance there has state from partition 0 and partition 2. Now, whatever state was associated with partition 2 needs to go to that 3rd instance. That's a lot to do. You don't want to write that code. So this is why Kafka Connect, haven't talked about Connect a lot here, but Connect as a data integration framework, same thing. You don't want to rewrite that. It's a lot harder than it sounds. Kafka Streams as a part of just open source Apache Kafka. This has emerged because people were doing stream processing and doing the same work over and over and over. And you want, ideally, one group of focused people to do that and lots of people to use it, so that that code can become what it really needs to be, rather than our own buggy partial implementations. And of course, the crown jewel of all this, KSQLDB, which is available as a fully managed component of Confluent Cloud, I can do all this stream processing there. So if I've got 6 topics that my new service, I've got some new service I want to stand up, and there are 6 topics that I've got the data that service needs. Well, I can use KSQLDB to join them, and I don't know, computed aggregation, do some filtering, mask some stuff, whatever it needs to do, and now create a new topic that's got that nice atomic unit of work. And that new topic could just pick up that message and naively consume it with the consumer API and go. KSQLDB can do all your stream processing heavy lifting, leaving your services to be simple. When you got more advanced logic, of course, if your services are in a JVM language, they can use Kafka Streams and do that same work inside the service as an API, giving your microservice stream processing capability. If you're doing data integration, for goodness sake, please use Connect. Whether you're doing self-hosted or you're using Confluent Cloud, it's all managed in Confluent Cloud and super easy. But even so, you don't want to rewrite bespoke data integration code. It does not differentiate your code against your competitors at all. So don't reinvent these things. Remember, Admiral Akbar says it's a trap. This is a key way to lose with event-driven architecture, is not use these tools. So if you want to win, don't reinvent your consumers. Don't reinvent the wheel. Use these frameworks. Now, scale isn't always the highest priority. We're not all Netflix. I think we like to pretend we're going to be, and sometimes scale really is a pressing concern. I think it's always a little bit of a concern. And more to the point, I think operations are a concern. So if you don't have to manage things yourselves, you really should use managed services. In the early days of event-driven architecture, I don't know if it was 4 or 5 years ago, and you were really, really cutting edge with this stuff, that was difficult then because you just couldn't do it. There aren't as many good reasons anymore. With the maturity of Confluent Cloud, there's just a lot of good reasons to use managed services. So, when it comes to the question of scale, it's always going to be easier to scale in the cloud. Kafka Summit Americas, which is just a few weeks before when I'm recording this, we had the VP of Instacart talking about their business. So if you don't know Instacart, that's like a shopping service. I give you my shopping list, and you go pick things up at the store, and you bring them home to me. During the beginning of the pandemic, they experienced like 10 years of growth in a few weeks. And so managed services were key to that. So these things can happen to you. But, when you think about scale, you want to think, how much am I really going to be doing? Is scale a pressing concern? Instacart, didn't think it was going to be. But you need to make a sober assessment of that. How much elasticity do you need? Right? Are you going to be going up and down? And how does that work? Are you going to go up suddenly? Is it going to be an organic thing over time? You need to think about that. And you need to be thinking about the difference between scaling storage and scaling compute. Those are different things. They scale differently. And so I think these are the things we ought to be thinking of. Back to this great diagram. Can't use this enough. This is an example of scaling compute. So scaling consumers, like I said before, is rough. You want to use Kafka streams probably for that. But even so, if you're using Kafka streams, then now I'm probably going to need Kubernetes or something like that when I add that extra instance, just to be able to make that happen operationally. Most folks these days are using some kind of management like that. And so that's an extra consideration now on my end that I have to think about. If I'm using streams, I still have consuming applications I need to scale. Scaling ksqldb is a little easier. So here's some ksqldb code that aggregates, it turns one stream into a table, computes an aggregation on another stream, and joins the aggregation to the table. So a pretty typical little piece of code. If you're running it as a managed service, well, if you need to scale it, you just say, hey, please give me more of these. It's a little bit easier to do. And now I've got that ksqldb cluster on which I can layer a bunch of my stream processing applications. Now, you're probably still scaling consumers, whether they're streams apps or not. You're going to have consumers. And so there may be some Kubernetes in your life or some way of managing that fleet of consuming applications around Kafka. But the more that I can push into managed services, the better. I think that story is becoming pretty well established now. You still have code that you have to run. You differentiate your business with that code against your competitors in some way. And so, it's not all a cloud service. There's something that you write and something that you manage. But the most that you can push, the more you can push into the cloud, into someone else's managed service, the better. When it comes to scaling storage, you've got two choices, right? I can make a bigger cluster, just add brokers effectively. Now in Confluent Cloud, you don't really think about brokers. Scale kind of happens in a different way. Brokers are abstracted away, but a bigger cluster is one way. Or we can add tiers. Now, these are just fundamentally the two options. And the first approach, this is like what a sequoia tree takes. Now, sequoia is a tree native to mostly Northern California. They are massive, massive conifers. And their approach to how to be a successful living thing has been to be enormous. That's what they do. Sequoias are big. That works, but it's expensive. And so scaling brokers to scale storage is an expensive way to do it. But there's something we've always done here to scale storage, and that is this tiering system. So this is a die. The picture on the left is a picture of a I think it's a Z80 die, a Z80 or Z8. Let's go with Z80. It's a Z80. So that was a general purpose microprocessor, 8-bit microprocessor in the late 70s, and it found its way into a few video game systems and a home computer and so forth. The picture on the right is zoomed into just the register file on the Z80, right? Not a lot of memory there. There's a few dozens of bytes, but very fast. Everyone can be accessed in a single clock cycle. Pretty expensive, but really, really fast. And then what do you have? You have dynamic RAM. Okay, Z80s, when they had dynamic RAM, it didn't look like this. We didn't do a lot of surface mount in the early 80s. But you got dynamic RAM, which is, orders of magnitude slower. You go registers, cache, RAM, and each one, you gain 1 or 2 orders of magnitude of size, 1 or more orders of magnitude of size, and you pay 1 or 2 orders of magnitude in the cost of accessing. And then, of course, you go to disk, and you know what? No, disks don't really look like this anymore, but I'll always remember disks this way. I think iconically, this is what disk storage looks like, and it's slower still than DRAM. It's the same thing if you're going to measure a distance. You might have calipers to measure some fine distance, or a ruler, or a tape measure, or a radio telescope interferometer or something. There's all kinds of ways of measuring distance depending on the distance. So, this idea of tiering is a thing that shows up over and over again in computer systems and in the physical world. So, with Confluent Cloud, you get tiering basically automatically. You can dump data in a topic past a certain age into the cloud blob store of your choice. You can also do this in Confluent Platform. So Confluent gives you this tiering thing for you. And I think this is really the way to win, because as you adopt event-driven architecture, you will want more and more to use, to have longer retention periods and more data in topics. As you adopt this paradigm and use it more natively, your topics don't get smaller. And you don't want that to mean very high cost, right? So you want a way, without just adding brokers and doing it in this really expensive way, you want to be able to push that data off into cloud blob storage, which is just a lot more cost effective. So tiering, I think, is a key way to succeed by, through managed services. Managed services are going to give you this kind of tiering more or less automatically, because the blob store is already in the cloud. Confluent Cloud gives you tiering. It's a great win. So let's just remind ourselves of these 5 things. We want to use events only when we need them. This is a great paradigm, but sometimes it's the wrong paradigm, and use mature judgment about that. It's a new thing. I know how it goes. I always want to do the new thing and the cutting edge thing as well, and the opportunity will come. It's often the right thing to do, but don't rush. All right. Make sure you use mature architectural judgment. Same thing with mature architectural judgment. Don't say, oh, databases, that was how mom and dad did it. We're too cool for databases now. We just have K-tables and topics, and that's everything. It's not true. You have databases. Okay, they should be in your system. Postgres, Mongo, Oracle, I don't even know what they are, but they should exist. And the difference, of course, is that they're not the system of record. They're not kind of on the throne as where everything goes to live. Topics are where data goes to live, and databases are materialized views of that record of events that we need to create, because we need to be able to access it in interesting ways, and databases do that. So it's different. Don't get rid of databases. Like I said, you might even have more of them now. I'm not sure. It might work out that way. Schema is the contract between services. If you want to be able to evolve services independently, if you want services to be able to emerge, if you want to kind of unlock the potential of evolutionary architecture, then you're going to need schemas. And you don't want to reinvent stream processing. Remember, Admiral Akbar said that framework is a trap. You've got Kafka Connect, you've got Kafka Streams, you've got KSQL DB. Connect and KSQL DB, fully managed parts of Confluent Cloud. So those are great things to use, and you want to make them a part of your life. Finally, I just mentioned managed services. You really want to use those whenever you can. At this point in the maturity of event-driven architecture, it's just such a viable option. There's no reason to shy away from this, because honestly, Confluent Cloud is pretty mature and is carrying a lot of production workloads. So it's a thing you should check out. With that, I want to point you one last time to Confluent Developer. That's developer.confluent.io. Lots of great things there. You could dive deep into technical details. There's some good big idea instruction, video courses, event-driven design patterns, executable tutorials. Sounds like a commercial at this point, but it's for your good. If you really want to learn this stuff, we've put a lot of work into this site, and it's for you to learn. So you can be successful using these 5 ways or other ways with your next event-driven system. Thanks.